Find the length of each side of the right triangle shown. So we're given this right triangle and we're told that the three sides are x, x plus 7, and 2x plus 1. We know that this is a right triangle. We're told in the problem it's a right triangle. Therefore, the Pythagorean theorem would hold, and it says that the sum of the squares of the legs, meaning we're going to square each leg, so we have x squared, and also x plus 7 squared. So the sum of the legs squared will equal the longest side, or the hypotenuse squared, which is 2x plus 1. So we'll also square 2x plus 1. So here's the equation that we need to solve for x. We'll go ahead and square both of our binomials. So we have our x squared. X plus 7 squared becomes x squared plus 14x plus 49. And 2x plus 1, the quantity squared, becomes 4x squared plus 4x plus 1. So I see I have a quadratic equation. Let's clean up the left-hand side. I can combine like terms on the left-hand side. X squared plus x squared is 2x squared plus our 14x plus 49, and it is equal to right-hand side 4x squared plus 4x plus 1. And now I see that I have a quadratic equation, and the only method we have now to solve a quadratic equation is by factoring. So I need my quadratic equation to equal 0. So I'm going to subtract all three of these terms from both sides of our equation. So 2x squared minus 4x squared, subtracting 4x squared from both sides, gives us negative 2x squared on the left. 14x minus 4x gives us positive 10x. And 49 minus 1 is a positive 48. And now I have my 0 on the right-hand side. We'll now try to factor the left-hand side. I see that the greatest common factor is not 1. We can factor a negative 2 out of all three terms. So factoring out a negative 2 leaves us with x squared minus 5x minus 24. And that is equal to 0. This factor can be factored further. We can factor it as the product of two binomials. X squared minus 5x minus 24 can be factored into x minus 8 and x plus 3. So now we'll use our zero product property. If these three factors multiplied together is giving me 0, then one of these two factors must equal 0, or both of them could. So we would say x minus 8 has to equal 0, or x plus 3 must equal 0. And solving each of these equations, we get x could equal 8, or x could equal negative 3. Now, due to the nature of this word problem, recall that x represents the length of a side of a triangle, and length cannot be measured in negative units. So because of the nature of this word problem, we must throw out the negative solution, the negative 3 solution. So x is equal to positive 8. So we'll go up to our diagram. If x is equal to 8, then this side, the other leg, is x plus 7, or 8 plus 7, 15. And the hypotenuse, 2 times x, or 2 times 8, 16 plus 1, 17. So the lengths of the three sides of this right triangle are 8, 15, and 17.